Hi, today we are doing lesson 5.2a, geometry, volume of prisms. So today our goal is to be able to find the volume of a prism. In order to start that, we need to know what a prism is. So prism is a figure that has two identical parallel faces that are polygons. And some examples are most boxes are prisms. An unsharpened hexagon-shaped pencil is a prism. And then it says your living room is a prism. But my living room isn't a prism. Because if we walk over to my living room, I have a vaulted ceiling. And so a vaulted ceiling doesn't have identical floor and ceiling bases. So it is not a prism. But maybe yours is. If your living room has got a flat ceiling and a flat roof, it's probably a prism. Okay, so a polygon, a figure that has two identical parallel faces that are polygons. In order to be a polygon, it has to be a closed shape with straight sides, so a triangle, a rectangle, a pentagon, a hexagon, etc. That's why we did in the last section, we found the areas and perimeters of triangles and rectangles and squares. Circles are not polygons because they don't have straight sides. So let's look at some examples of prisms. So a rectangular prism. Oh, by the way, a prism is named by the base shape. So all of the sides of a prism, the sides that are not considered bases, are always going to be a rectangle shape. But the bases themselves, the top and bottom, if you stand them up, the parallel bases are what makes the name of the prism. So this one has a five-sided, a pentagon on its base, pentagon on the front, pentagon on the back. So it's a pentagonal prism. This one has a triangle on each end with rectangles between. So it's a triangular prism. And this one has a hexagon on the top and on the bottom and rectangles in between. And that's a hexagonal prism. So if you think of a prism as being a box, the top of the box and the bottom of the box are going to be one shape. The sides of the boxes are going to go straight from the bottom up. They're all going to be rectangles. And so just because I say a box doesn't mean it has to be rectangular on top. You can have one of those old-fashioned hat boxes. Those are hexagonal prisms, if you've ever seen one of those. If not, look it up, old-fashioned hat box. Okay, things that are not prisms. This guy, because he has a pointy top, so he has a pentagon on the bottom, but not a pentagon on the top. This guy, because he has a circle on the top and the bottom, and a circle is not a polygon. This guy, because he's like rounded on one side, so that is not a polygon, can't have rounded sides. So decide if the solid shown is a prism or not, and if it's a base shape, trace over the height of the prism. If it's not a prism, tell why it's not a prism. So I'm going to get red for my height of the prism, and then I can circle. So this is not a prism. Why not? Because it's round. Round is not a prism. This one is a prism. And if it is a prism, we have to draw its base shape. So its base is a triangle. My computer is really jaggedy here. And the height of the prism is the distance from base to base. So even though this looks like a tent, and we have a triangle on the front and a triangle on the back, the height is still the distance from base to base. So the height is this distance right here. Well, if it were straight. That distance right there, that's the height. Okay? Is this a prism? You bet it is. Why or why not? I'm going to try a different thing here. It's like my whole computer is on super slow-mo. I'll get back in and see if that helps. All right, so here we go. So yes, it's a prism. And the height of the prism is the distance from base to base. Now we can't see the other base, but we know it's down there, so this is the height. And you can pick any one of these lines to show the height. All right, moving on. Is this a prism? No. Why not? Because it has a pointy tip. Pointy tips don't make prisms. You have to have the same base on the bottom and the top. Is this a prism? You bet it is. How do we know? Well, oh, I crossed it off and said underlined. I know because it has a rectangular base, and it could be this one, it could be this one, or it could be this one. It doesn't matter because they're all rectangles on this shape. And so any one of them can be the height. So if we want to look at it just as it is, set up kind of like a Kleenex box, then this is the base on the top, the bottom base we can't see, and the height is right here. If you wanted to stand it on its edge, kind of like a cereal box, and you wanted to turn it so it stood up like this, then the height would be here. If you wanted to set it, I don't even know if I can make it kind of look like this. If you wanted to set it this, nah, never mind. We could set it this way. I don't know what shape like that. Maybe a Lego box, because it's usually wide on the front for the picture. Then this would be the height. So when you have a rectangular prism, any one of the edges can be a height. All right, this cone, is it a prism? Nope, got a pointy part and a rounded part. Definitely not a prism. How about this one, a cylinder? Nope, not a prism. How do we know? Because, well, first of all, because it's cylinder, but also because it's got a round part and it does not have rectangular sides. It has like one long side. Prism or not a prism? Not a prism. It's got a pointy part. No pointy parts on prisms. It's got a triangle base. It has to have a triangle top. Prism or not? Yeah, it's a prism. I forgot to circle not. And how do I know? Because it's got the same polygon or rectangle or square on the top as on the bottom. And the height, once again, can be any one of these sides. All right, so we are finding volume in this section. So the first one was about area and perimeter, the first section. This section is about volume. And the section of the chapter that we're going to do after holiday break is surface area. So we're focused on volume for the next 3 or 4 days. So the volume is the space inside a three-dimensional object, and it's measured in cubic units. So we're thinking about how many cubes will it take to fill up something. So we're not talking about one flat piece. We're talking about how many little cubes could we use to fill something up. And usually when we're trying to fill something with cubes, we'd have to kind of cut our cubes apart and rearrange them in there. They're not going to just fit nicely, but that's the idea of what we're doing. To find the volume of a prism, you take the area of the base. Now again, area is what we just finished learning about, so that was the purpose for that, of the base times the height of the prism. And we write that as capital B, which stands for area of the base, times the height. So this does not mean a base length or a base width, it means the area of the base. And I will usually write out area of the base times the height instead of capital BH, but that's what that means. Remember, the base is the parallel faces of a prism. And here's just a reminder of how to find some areas. So the area of a rectangle is length times width. And these swirly letters are how we write those, because if we write L like that, it kind of looks like a 1. So usually if we're trying to show that it's the length, we'll write a swirly L and a swirly W. Cursive, they're cursive. The area of a triangle is base times height divided by 2. That was on the quiz. And then we have area of a regular hexagon. And so this one is a little different. We haven't talked about this one yet, but it's not very hard. We have, if you think about it, a hexagon, a regular hexagon, is a bunch of triangles hooked together. So we find the area of one triangle, base times height divided by 2. And once we know the area of this rectangle, then we multiply that by the 6 pieces that are all the same. So if I knew the area of this, for instance, was, say, 3. If this one was 3, then this is 3, this is 3, this is 3, this is 3, this is 3. The area of the whole thing is 3 times 6, or 18. All right, so quick review. Find the area of each polygon. I hope I don't need to help you remember how to do this one and this one. So I'm just going to write their answers. You write yours and then look up and see if you're correct. All right. 8 times 6 is 48. 4 times 7 divided by 2 is 14 feet squared and centimeters squared. Now we have the hexagon-shaped one. So I'm going to start by finding the area of this triangle, and I just realized that the example I made up was a really good example up here. Because if this is 2 yards in height and this is 3 yards in base, because this is a regular hexagon, so all the bases are the same, then I would find the area of this triangle by doing 3 times 2 divided by 2, and 3 times 2 is 6, and 6 divided by 2 is 3. So, just like in the example I did above, this triangle has an area of 3, which means all of these have an area of 3, and 3 times 6 is 18. So this regular hexagon has an area of 18 yards squared, or 18 square yards. Okay? Next page. Next page is an activity that if we were in school, we'd be able to actually build these in with unit cubes. So we'd have little centimeter cubes or inch cubes, or one lucky group would even get to use cube-shaped Kleenex boxes that are like this big and build this huge tower out of them, but we're not at school. So here's what I'm going to just summarize this page. If you know how many cubes fit in one layer, then you multiply that many cubes by how tall something is to find its volume. So how many cubes do you need to make a 4 by 3? You need 12. The dimensions are length is 4, width is 3, height is 1. Put another layer on top, so I'm going to double that. Clone it, okay? Now I got it doubled. So now it's this tall, right? So now, how many cubes did it take? Well, I used twice as many cubes because I made it twice as tall, so now I got 24. And the new dimensions, it's still 4 long, it's still 3 wide, but now it's 2 tall. Moving on, how many cubes did you need to make it? Oh, add another layer. Sorry, I missed that important step. Add another layer. Clone it. Build it on top. Now, how many cubes did I need? Well, I have 12, 12, and 12, so now I have 36. We made a prism. Well, we had a prism to start with, but what is the base shape of our prism? It's a rectangle. See right here, rectangle. What is the area of the base shape? Well, the area is 3 times 4, so that's 12. What is the height of this prism? 1, 2, 3 cubes tall, so 3. Multiply the base by the height, and I get 36. And where have we seen that before? We saw it right up there. Okay, imagine that you build one that is 10 layers tall. How many cubes would it take to make it? What would be its volume? Well, it would be 4 by 3 with a height of 10. So each of the layers would be 12 cubes big, and we have 10 layers of that. So 12 times 10 would be 120 cubes. I didn't have that many Kleenex boxes, so it's okay. Draw a triangle on your graph that is 3 units high and 4 units wide. Let's draw it right straight up and down. 3 by 4. Now I'm going to just connect it like this because it's a triangle. So I made a right triangle. Estimate the number of cubes that could fit inside your triangle. So 1, 2, 3, 4, 5, 6. Oh, 6. What measure are we approximating? We're approximating area, how many squares fit inside something. This should say squares. Wow, that was terrible. I need to fix that. Squares. So we're measuring area. Okay, use the formula to find the area of the triangle. The formula is base 3 times height 4 divided by 2. 3 times 4 is 12. 12 divided by 2 is 6. 6 square units. If the triangular prism was 7 layers tall, what would be its volume? So it's got 6 cubes per layer for 7 layers. I'm building it towards me. 6 times 7 is 42. Create a formula for finding the volume of any prism. I hope you find a volume that says take the area of the base and multiply that, that says base, times the height of the prism. All right, let's do some examples, like your homework. Or we're going to start the homework together. This will help you out a little bit. The units when measuring volume, I heart volume. So I'm going to write the V, and I'm going to make it a heart. See, it's a heart. I heart volume. And look, if I take that and turn it, not that part, this part, if I turn it, it's a 3. I heart volume. Somebody should make a GIF of that. So it is cubed because we make it out of cubes. The units when measuring area are, area is made of squares, so it's squared. All right, so I'm going to jump down and I'm going to do number 6 with you, and then I'll let you start your homework on your own. So it says, first of all, draw the base shape. So I'm looking, what is the base that's on opposite sides of the prism? It's a triangle, so I'm drawing my triangle. And it shows right here that there's a right angle, and next to the right angle it says 3 inches. So straight down the middle with the right angle, this is 3 inches. And then this is the base of that triangle. So I'm going to go down here and see that that's 5 inches. So the area of the base is 5 times 3 divided by 2. 15 divided by 2 is 7.5. So 7.5 inches squared. That's the area. The height of the prism. The height of the prism is the distance from base to base. So here's one base. Here's the other base. This is the distance between them. That's the same as this one. So it's 14 inches. There's no calculating for height. You just look and you find it. Okay, and then volume of the prism. This is the easy step. Take the area of the base times the height, and that gives you the volume. So 7.5 times 14. 7.5 times 14 is, I'm using my trusty dusty phone, 105. 105. And then my volume is in inches to the 3rd power, because I did inches to the 2nd power times inches to the 1st power, and I got inches to the 3rd power. And that's how you're going to do these problems. Okay? Up here. Backside. You're just going to have words to describe the shape instead of a picture. Just draw on the picture or draw your own picture and put the measurements on there so you can see what you are measuring. And then there's some review of the last section and some review of the chapter with, this is actually chapter 1 when we did positives and negatives. All right, that's it. See you tomorrow. No, I'll see you in the meeting maybe. See you later, alligators. Bye.